Okay, boss. Now we have to deal with partitioning. So the last class we've seen about while creating a table, how do we set the unload priority? And while creating a table, how do you basically enable or disable your auto merge? On, auto merge is like switching on. Just saying auto merge is like what? Switching off. Okay. Even after creating the table, you can still alter the table, disable, enable the auto merge. The auto merge is enabled, system will take care about merging. That's it. If it is disabled, we'll have to explicitly perform the merging on the table. Yeah. Then we've seen about temporary table, global temporary table. Now partitioning was. So what is partitioning? Say I have a table. I would say I would partition a table. What does it mean about partitioning? Yeah, dividing of what? Columns or rows? Rows. So when you say partitioning, you divide horizontally, not vertically, right? You divide the table in horizontally into multiple partitions or multiple blocks. That is partition. So you have a table. You split the rows of a table into multiple blocks. That is what we call it as partitioning. And see, then how does it partition? Let's say I have 1 lakh records. How do you decide which data will get into which block? That depends on partition specifications. Say when you're partitioning a table, you would specify some specification saying this is my specification of the partition. Based on that, the data is grouped accordingly. Let's say I've got 1 lakh records in a table and I create some 10 partitions on a table. How do you decide which record of a table gets into which block? That depends on partition specifications. Depending on what type of partition are we doing and what partition specifications are we specifying, the data is grouped accordingly. Okay. Now, first, before we go on seeing our types of partitioning, what is benefits of partitioning? Generally in BW, why do you do partitioning? We partition the cube, right? For improving query performance. In what way does it improve performance? Let's say your partition based month wise, you're running a query, you're running a report or query for only a particular month. Instead of scanning through all the entire table, it just does catch hold of the partition which is holding that particular month and picks data from there. That is what we call a pruning. Partition pruning. Yeah? Let's see, apart from this, now look at this. Load balancing in a distributed system. When I was referring to HANA architecture, I was referring saying we can install HANA with a single load. Rasko mottham on the matter on the okay. So when you say load distribution, when you are installing HANA server, it could be single node or it could be distributed node. But single system lo HANA server install cheyochu, 4 system lu kalipi HANA server laga install cheyochu. It could be a single node or distributed. Suppose if let's say what I've done is I've got 4 HANA servers, 4 servers together is been configured as one HANA server. So I've installed HANA in a distributed environment. So then what I want is, let's say I have a table and I would like to split this table content into 4 different servers which are representing same HANA server only. It is all one HANA database software distributed across 4 different servers internally, 4 hosts. Okay. So then I would like to distribute my table content into each block, each of the server separately. So when I run my query, it puts pressure on all the servers. If my table, let's say, you remember in SAP, when you go to SM51, you see one application server or multiple applications. What does that mean? You'll have one central instance, you'll have multiple dialog instances. Same way here also, if you want to have really big server, you'll have one central instance and multiple dialog instances together will be configured as one HANA server. Bundle of servers together as one HANA server. That is distributed environment. So let's say I've got 4 index servers together contributing as one HANA server for me. Okay. In that case, if I store my table in only one index server 1, okay, when I run the query, the pressure is all on to what? One index server, because the table is in the index server 1. Suppose let's say I've installed in a distributed environment where I've got 4 index servers. If I distribute this table into 4 different servers, part of the table into index server 1, part of the table into index server 2, part of the table into index server 3, index server 4, which is contributing as one HANA server. Now when I run the query, does it basically put pressure on all the 4 index servers? Yeah. So by enabling partitioning on a table, we can enable load balancing. We can basically split the load among all the servers, load distribution. Okay. Then overcoming with the size of the table is also a benefit for us. I told you each table can hold up to 2 terabyte, up to 2 billion rows is maximum. In a given table, maximum 2 billion rows is max. But let's say I have a requirement that I would like to hold more than that. Then I can create a partition where each partition will have the limitation of 2 billion rows. Actual limitation is each table is going to hold 2 billion rows max. But if you want to go overcome with it, what I can do is I can create 5 partitions. Then it becomes like each partition can go up to 2 billion rows. Then I'm able to store 10 billion rows into it. So I can also leverage partitioning when I want to overcome with this limitation of the size of this column store table also. That is one more benefit. Next, parallelization. Same. So if I have my data distributed across multiple servers, when I run my query, obviously query will have parallelism. Like I can have 4 threads running in. Thread 1 reading data from server 1, thread 2 reading data from server 2, thread 3 reading data from server 3, and thread 4 reading from. So I can have 4 threads reading data parallelly and giving me deploying parallelism there and improving my query performance also. That is also going to benefit for me.
You say multitasking is same as parallel?
Yeah. Multi-threading, multitasking. Yeah. Then partition pruning, again, same. Say for example, I have partitioned my table where it stores each partition stores a particular month of a data. Say January month, Feb, March, April. And when you run a query, you're running query only for Feb. Obviously, it will not scan through all the partitions. It will straight away scans only the partition which is storing Feb and reads data from there. That is called a partitioning pruning. Instead of scanning through entire table, since we have created a blocks saying for each month wise, like say Jan, Feb, March, April, and I'm trying to run my query only for Feb, it actually reads data only for what? Feb. That improves your query performance again. Okay. And it also improves the performance of delta merging. So partitioning table is not only for query performance, we also take care about delta merge performance also. So let's say I have a table. I told you every column store table will have main and delta, and when you do delta merging, it has write records from main to what? Delta. Again, I explicitly told you if a table has got 5 partitions, each partition will have main and delta separately. Each partition will have main and delta separately, right? And the merging is done separately for each partition, right? Now let's say I've got 10 partitions and you load a new set of data. Let's say the new set of data is loaded only for 10th partition. Then when you do merging is done only on 10th partition, not on the other 9. Then that improves the performance of your merging also. అంటే అంత డేటా మీద మర్జింగ్ చేసేదానికంటే ఆ బ్లాక్ లో కొత్త రికార్డ్స్ వచ్చినప్పుడు ఆ బ్లాక్ మాత్రం మర్జింగ్ చేస్తున్నారు. సో దట్ అగైన్ ఇంప్రూవ్స్ ద పర్ఫార్మెన్స్ ఆఫ్ డెల్టా మర్జ్ ఆపరేషన్. దట్ ఈస్ వెరీ 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 ఇంపార్టెంట్ because the question comes like this. So in BW you have a cube, right? So we already declared that even though when you store data in a detailed format, system can handle the performance. We already declared that even though the table stores data in a very detailed format, not aggregated, detailed, system can handle the performance because it is a column store. Then why do you want to do partitioning? Got the question? Even though data in my cube or data in a table is very detailed, system is able to handle the performance because it is a column store, because each stores only unique values and indexing is available, so it improves my query performance. Then why do you need to do partitioning on a table is what the question is. Right? Because the partitioning may not really improve query performance to a larger extent because it is already handling the detailed storing of data, because the way it stores is completely different. So the major benefit of partitioning the cube would be improving your delta merge operations. Now our focus is not about, we are not partitioning the cube in BW to improve query performance. We are partitioning to improve the delta merge operation on the table, on the fact table. That is our focus. Okay, boss? And then explicit partition handling, let's say, same like in BW, we can always create new add new partitions, merge partitions, delete a partition, anything can be done. For example, I've created 12 partitions for 12 months from January to December, let's say. And next year data, I would like to add one more partition for Jan 2017, Feb 2017. I can keep adding explicit partitions also. Even though the partitions are not still having data, I can still create explicit partitions. See, as of now, my table has got data only for 2016. There's no data for 2017 or 18 or 19. I can still say create partitions for 4 years for each month wise. Then it creates 12 into 4, 48 partitions. Even though there's no data for the future years, it can still create explicit partitions also possible. So basic benefit is about parallelization, load balancing, query performance, and delta merge, improving the performance of delta. That is what the benefits are. Okay. Okay. Now you decided about partitioning a table. Now once you decide about partitioning a table, there are 3 ways of doing it. One is hash partitioning, and then we got round robin and range partitioning. We have 3 ways of partitioning it. See, again what it does is, when you look at partitioning a table, there will be 2 categories. One is single level partitioning, multi-level partitioning. When it's a single level, you're just using only one partitioning criteria. When you use multiple partitioning criteria, then that becomes multi-level. When you come, let's say I've got hash, round robin, range. When I mix up saying, first it has to do hash partitioning. Again, within each hash partition, I want range partitions. That is good. Multi-level. So you could have single level partitioning or what? Multi-level partitioning. Okay. For single level, we're focusing on this. We have 3 types of partitioning. One is hash partitioning. Say once you decide about partitioning a table, you can partition it either on based of hash partitioning or what? Round robin or range. Okay. Only okay. We'll come to that. Now first is hash partitioning. This is about now when do we use hash partitioning generally? When you are working on a distributed systems. Generally, your HANA server has been installed on multiple hosts, or it means like you got multiple index servers. Then you would like to split this table equally and then divide that into each, store it each server separately. Let's say if I got 4 index servers, I would like to split the data into equally into 4 blocks and put each block into one server. That is the kind of scenario you go with what? Hash partition. You specify, you actually what you do is, you specify a column on which the hash partition must be done. Then it does use some hash function internally, and then based on the values of that column, it says, okay, all the values of this column is one block, all the values of this column is one block, all the values of this column is one block. Then puts each block into one index server. That is called as hash partition. So now look at this, what I'm saying. I'm just saying while creating a table itself, we can configure the partitions. Or after the table is created also, I can create hash partitionings on the table, either ways. Even when there is data in the table, I can create partitions, no issues. Okay, boss? See, while creating table, I can create partitions. After the table is created, I can alter the table and create partitions. Or even when there is data in the table, I can still go over creating partitions, no issues. Now look at this. Saying create so-and-so table, and I've got 2 columns, employee ID and name. I'm saying partition by what? Hash using which column? Employee ID, and number of partitions, how many you want? 4. You are explicitly deciding how many you want, 4 or something. But I don't want that. I would like to say, like any index server, then what I'll do? I can use this function, get number underscore servers. So if I use this function, if I've installed my HANA server with a distributed system with 4 index servers, obviously it creates 4 partitions. If I've got only 3, then it creates 3 partitions. So you can use this dynamic function, get underscore num underscore servers, which will give you number of servers available.
System defined function.
Yeah, system defined function. But if I use this now, server mine is a single host installation, right? So it will have only one index. So but I still want to see 4 partitions. See, generally hash is used to split the table content across multiple nodes in case of a distributed installation of HANA server. So నాకు ఎన్ని ఇండెక్స్ సర్వర్లు ఉంటే అన్ని పార్టీషన్స్ కావాలంటే డైనమిక్ యూ కెన్ సే గెట్ num underscore server function to decide how many servers we have. But for now I don't have so many. I have only one. It's a single host installation, so I have only one index server. Yeah, I'm coming to that. Okay. Now she's asking, now the column what I'm using for partitioning, should that be primary key? Yes. For hash partitioning, what are the column you're using for partitioning must be a primary key. Suppose if I have two columns are primary key, the hash partition must be used using both the columns. Complete primary key must be used for partitioning hash partitioning. So when you're partitioning a table using hash partitioning, complete primary key must be used. Okay. So but look at this. Now in this case, are we controlling saying record 1 should go into partition 1, record 2 should go into partition 2? No, we can't control. That is all. There's some algorithm called hash function which system will define which record should move to which block. Based on you specify a column called employee ID, it does use some hash function and defines which values of this employee ID column must be moved to which block. But we cannot decide, okay, these values of employee ID must be getting into partition 1, these values of employee ID must be getting into this. We can't control that. If you want to explicitly control the records into partition based on the value or value range of values, then you have to go to range partition. In case hash partitioning, you cannot control based on the values. If you want to control the partition based on the values, it has to be a range partitioning only. In case of hash, it actually divides the data across multiple servers. And how does it split the data? Based on hash function, and hash function is executed on which column? The column what is specified in the partition class, and the column what is specified in the partition class must be part of primary key of the table. Yeah. So I'm just creating a table with creating hash partitions on it. So my schema is 9. So I'm just creating this table, okay? So I'm saying normal, and I'm just adding this class partition by what? Hash. And which column am I using for partitioning? Employee ID. That must be part of primary. If I have got two columns as primary key, I must specify both the columns, column 1, comma, column 2. Yes, okay. And the number of partitions. If I have server number, I'm just saying 4. And then, okay, first let's see the table. EMP hash. So if I see the definition, I can see the partitions created. If I go to definition, if I go to the runtime information, I can see this. Look at this. What is parts? Which shows partitions. When I expand this, I see 1, 2, 3. How many partitions it is created? 4. And each partition will have main store, delta store. And it will tell you what is the total size of, see, main size, delta size, and what is this? Size of my main store, size of my delta store. And you also see the record count in each partition. And here it tells you the partition specification. I told you partitions are created based on partition specifications. And what is this here? Hash and number of partitions 4 on which column? Employee. Here you see the partition specifications, and here you see the partitions. But in this case, all the partitions are created on the same index server, same server. Look at the same host. In the real time, if you have distributed system, when you say get number of servers, you will see partition 1 is on one host, partition 2 will be on another host, partition 3 will be on another host, partition 4 will be on another host. Wherever a host lo untundi. Ikan నాకు single host got anni ote unnai. Okay. So then, if I just insert some records into this. I get 4 records, fine. Look at this. It says 2 records it is put into partition 1, and it is, sorry, 1 record it is put into partition 1, and 3 records it is put into partition number 4. We cannot control it. There got some hash logic algorithm internally which divides it. Clear on this? And basically, when you associate a partition with one particular server like that, then you go with what has partition. Now look, now the point is, in what kind of scenario I would go with hash partitioning. Okay. So with hash partitioning, you only get two benefits. Only for two benefits you would prefer hash. One is, look at this. I told you are getting so many benefits with partitioning, right? With the help of hash partitioning, you get only two benefits. One is about load balancing. Yes or no? When you perform an hash partitioning on a table, by using hash functionality, it does split the records into multiple, creates multiple blocks, and each block is stored into one different host. So I am achieving load balancing now. When I execute a query, it puts pressure onto all the servers to read the database. So by using hash partitioning, we can achieve load balancing. That is one option. And other option of using hash part would be to go through the limit of 2 billion rows in a table. Suppose if the table exceeds 2 billion rows, even then I can go with hash partition where it splits into multiple blocks, and each block can go up to 2 billion rows. That also can. But I cannot really, this will not really help me to improve this query performance or pruning or something like that. Because we said we have an option called partition pruning. Pruning అంటే ఒక్కొక్క మంత్ సపరేట్ బ్లాక్ ఉండి క్వెరీ కొట్టడం ఆ బ్లాక్ రీడ్ చేసేది అలా లేదు ఇప్పుడు. ఎందుకంటే సపోజ్ వెన్ ఐ డు హ్యాష్ పార్టీషనింగ్, the data of the same month might be available in all the 4 blocks. Let's say January data might be in block 1, block 2, block 3, block 4. When you run the query for January month, it might has to read data from all the 4. You create the difference. I'm splitting my data, then asking all the systems, all the servers to work in and read and then deploy. So am I achieving pruning here? Pruning ante per month పెడితే ఆ బ్లాక్ ఎత్తుకొస్తుందో లేదు. ఏ డేటాను ఎనీ క్వెరీ యూ రన్, ఇట్ ఈస్ గోయింగ్ టు రీడ్ ఫ్రమ్ వేర్ all the blocks. So the only so the hash partitioning scenario in the, when you want to do load balancing across multiple servers and then you want to overcome with the limit of 2 billion rows per table, you would go with hash partitioning. And whenever you're doing hash partitioning specification must hold the primary key of the table. If there are 2 columns, both columns must be there. And number of partitions depends on number of servers you have generally, and that can be made dynamic by using that function get num servers. Clear on this? Yeah.
Yeah, sir. For hash partitioning, it is more useful for load balancing.
Ante, yeah.
And for pruning,
distributed environment where you got installed with multiple node servers, then I would like to do load balancing. Then I would go with what? Hash partition. Yeah.
Okay. So pruning, which is used for data query performance.
I'll come to that. When we see range partitioning, we'll see that. I'll come to that.
Okay.
Sir, can we see that one record in that partition, sir? 1 and 3 records.
Excellent question. Yeah. He's saying, now here it tells me in partition 1 I've got record 1, in partition 3 I've got record 3. దీనికి ఎలా కావాలంటే ఆ బ్లాక్ లేకపోతే ఒక రికార్డ్ కనపడదు, ఈ బ్లాక్ లేకపోతే ఒక రికార్డ్ అట్లా చేయదు అన్నట్టు. It doesn't give like, because what they want, see, these partitions should be transparent for your SQL statements. Generally, let's say now I would like to read data from this table. What table is this? EMP hash kada. When I say select star from 9 cubics SQL, is it reading from partition 1 or 2 or 3 or 4? So internally the blocking is done, partitions are created physically, but for SQL they are transparent, means like they don't see it as a different blocks, they see it as all as depend with only table name only. So each partition will not have any name like say table name dot partition 1 allowed. You will not be able to see దాంట్లో చూపి అలా ఉండదు. You cannot see query, you cannot use that in the where clause saying show me only partition 1 data, no, because that is transparent for my SQL statements. SQL statement always refers that as one table only always. Okay, boss? Can we create, yeah, I'll show you. You're saying can we create partitions on UI level? Yes, I'll come to that.
Sir, it will not benefit for delta merging also? Hash partition?
No, this will not benefit for delta merging also. Because now he's asking, will this benefit with delta merging? No, because let's say I insert, let's say 7 more records. Okay, let's say I can take the same data. I insert some more. I'll say 5. I'll say 6. I'll say 7. I'll say 8. And let me insert again. Now, in which partition does this get in? Do we have the control? No, they can get it any partition, right? Now, look at this. Now, actually, got 1 to 3 1 in already. Now, I insert 4 more records. 1 record has come here, 1 record has come here, 2 records have come here. Now, it has to do merging for which partitions? Partition number 2, partition number 3, and 4. Partition 1 need not, because it was already merged up. Assume that there is 1 record in partition 1 where merging was already done. So, there is no new records into partition 1. So, now merging is done on all the 3 because there has been new data in partition 2, there has been new data inserted into partition number 3, there has been new data into partition number 4. So, delta merging is required for all the 3 blocks. That would not help me. Suppose if, let's say, like next scenario we will see round robin. The pure concept of round robin would be of improving performance of delta merging. We'll see that. You understand why it does not improve delta merging? When I'm inserting records, all the new records what I insert are not going into one partition. They are all getting in, splitting across partitions. So obviously merging has to, when you do merging will be done on all the partitions. We cannot control. But if the scenario situation is like this, say what are the records, new records I insert, they all get into one new partition, and then merging will be done on only that partition. Then it improves my delta merge operations. That is what happens with round robins. Got this point? Yeah. Okay, boss?
Yes, sir.
Yeah. Now next round robin, boss. See, this is some, okay, he was asking, well, let me finish this and I'll come to that. Ask me how do I create range partitioning with UI bus. So what I'm doing, I'm creating a table like this. First I'm creating this table, employee hash UI. I want to create hash partitions with UI bus. This is a table. Okay, you can right click on this tables folder. You have this option called what? Show table distribution, or you can right click on this schema. You have this option called show table distribution. Either ways you can do. Select this option. Which table you would like to partition was employee hash UI. The below it shows me there have been no partitions yet. So right click on this table and say partition the table. Now you want to partition the table by what? Hash or range? Round robin UI. Only hash or range. I'll say what? Hash number of partitions equal to number of hosts. Ante mana function get num server and a function. No, I would like to specify how many you want. I want to go with say 2. Okay. Is your additional level? I told you there is like multi-level partitioning or single level partitioning. Multi-level, first you will say with hash. Again, you want to have multiple levels. Then I will go with otherwise no. That is enough hash, and I want to. When you say next, ask me which column. See, it's showing allow me only to choose only the primary key columns only. Employee ID. Okay, finish. This is about creating partitions. So now when this table is selected, it will show me those what 2 partitions. With the UI, this is how you create a hash partition.
Number of servers and partitions must not be the same.
Number of servers. Hash lo general ga alaga undali. Hash makes sense only when number of partitions are equal to number of servers. That makes sense.
But you have one index server.
ఇక్కడ నాకు ఊరు బ్లాగులు చూపిల్లంతే. Real table మాత్రం number of servers ఎన్ని ఉంటే అన్నీ వెళ్తాం. ఇంకా there is a discussion, say for example now we have 4 index servers. Okay, we create 4 partitions. Let's say now there is a failure of one index server and you create one more host now. Now what are the data we had in this partition has to be moved to another partition. Like this we can alter the partition where we change the movement, we change this location of the partition to another index. By alter, we can alter the partition that way also. Yeah? Now next.
Sir, hash partition.
Yeah.
Sir, a hash partitioner distributes the table into as many servers we have, right?
Exactly.
So, okay, that is okay in the real time. But as of now, as we have a single host server, so how does it make? How is it making the difference?
No, it is
when we are giving 4 partitions?
Yeah, it is actually creating all the 4 partitions into one itself. It is not mandatory that it must have all the 4 nodes. The scenario would be it divides into blocks, splits across servers. But if you don't have that, then what if I specify some number, it creates all those blocks within my same index.
Okay, at least the table size will increase. We can think it that way, right?
In that case, we will be going with only the second benefit where the limit of the sizing of the table is being controlled with this.
Okay. And sir, this voice is breaking very frequently.
Yeah, when you're in a single node, you don't have the benefit of having load balancing because there is no multiple node. So the only benefit you would get is about we are overcoming with the size of the table with more than 2 billion rows, then he can have this partition script. Yeah.
Okay. Sir, your voice is breaking very frequently today.
I think I'm okay from my side. I'm fine. Something is it the same with everyone, boss? So Vijay Kumar says voice is clear. So something should be from your side, please. Yeah. Then round robin, boss. So this is majorly for improving delta merge operation. This is the one we use. Okay. If you have a table where you're really focusing on improving the performance of delta merging, we use this option called round robin partition. So basically when you say round robin, it creates partitions. Even in this case, the partitions can be spread across multiple hosts or it could be in single host also. No, that does not make any difference here. Okay. It could be distributed across multiple. If this is distributed across multiple hosts, you will have the load balancing. If it is in same host, you will not have load balancing. That's it. Otherwise, no difference. Okay. But the only thing is, when you're going with round robin, you are not partitioning on any specific column. No column is specified. No column is. In case of hash, you say, I want based on the values of this column. Right? There's no column specified for round robin at all. Okay. And moreover, the table must not have any primary key when you're going with round robin partition. The table must not have any primary key if you have to create a round robin partition. And in the partition specification, you will not have specify any column. No column is specified. You just say how many blocks you want. Okay. So then when you create 4 blocks, how are these 4 blocks being used? In case of round robin, all the new data what you insert will get into one partition. And then the delta merging is done only on that block. So whether the data movement from one partition to another partition is all controlled by the application running on the tables. Say for example, now try to understand this first. Now try to understand, say for example, see you have info cube, right? Your info cube actually creates round robin only. Okay. Generally it will be a fact table with 4 partitions. It's partition 1, partition 2, partition 3 and partition 4. Okay, boss? The backend fact table of info cube is partitioned by round robin with 4 partitions like this. Okay. So as this is all a cube, right? All this is what? Is a cube. You configure transformations, you run the DTP, let's say you're loading database. Okay. Every time you load some data and the new records into that cube, it gets loaded, let's say you load 100 records and the 100 records will come into partition number 4. The 100 records will come into partition number 4 always. Okay. Now in the cube, we have a process called compression. Yeah. Normally when you do compress the data from this partition 4 is moved to partition number 1. So it will treat as if the partition 4 is like F table, partition 1 is like E tables. Again, let's say again you run a DTP. Again, some new set of data is loaded. Let's say you loaded 200 records now this time. Then now if you do merging, where is my new records inserted? Assume this for this 100 records, the merging was already done. Let's say now again you load new set of data. The 200 records have come into which partition now? Partition number 4. So new record changes has been done into which block? Only partition number 4. So merging should be done only on what? Partition number 4. Then again, when in the BW system, when you do compression, again it takes this 200 records and adds it to what? Something. It keeps adding to that partition one. Again, this data is deleted. Again, new data comes in. Again, partition number 4. Again, you do compression. Data gets to partition number 1. Okay. Now your question should be, what is the purpose of partition number 2 and 3? Partition number 2 and 3 is only used for non-cumulative cube, like inventory cube. Partition number 2 and 3 will be used only for in case of non-cumulative cube. When you're dealing with inventory management, you deal with something called non-cumulative key figures. So you remember we'll have something called initial stock, and then we'll have movements. See, when you even when you load the inventory data, first data will come into what? Let's say you loaded initial stock. It comes into which block? Partition number 4. Again, when you compress saying with marker, you remove marker without, and then the initial stock will get into partition number 2, and movements will get into partition number 3. But ultimately, any data you load, first it has to enter what? The new records what you load always gets into new block, which is what? Partition number 4. Then when you're doing compression, it moves into P1 or P2 or P3 depending on the case. If it is normal cube, it moves into P1. If it is non-cumulative cube with initial stock, it moves the data into what? P2. If it is movements, then it moves into what? P3. So actually, when you say round robin is what? For all the new records what you load, I want like to collect that into separate part block. And from then onwards, I would like to move into different blocks. My application will take care about moving those records. We are not controlling it. So the BW application which is running on HANA, when you do compression in BW, then the records of my partition 4 are moved into partition 1 or 2 or 3 depending on the case. That we are not worried. When you say round robin, it actually has a separate block, and all the new records what you enter into the table will get and sit into one separate partition. That is round robin. And from there, how it takes into different partitions depends on how application is leveraging that. Round robin is about providing a platform or providing a block for all the new records to come and sit into that, so that the delta merging is done only on that particular block. Then how the records are moved from this partition to other partitions depends on how your application running on the table is controlling them. We are not worried about that. So round robin is just about providing a separate block for all the new records what you are loading. And then, so the new records are reflected only into one block. So then the delta merging should be done on only what? Only on that partition block only. That's it. So the major focus of round robin is about improving performance of delta merging, not query performance, not load balancing. Only focusing on delta merging. Clear this?
This is important only for summary data.
No, summary, any kind of data. Okay, boss? So I'll show you.
Sir, you told that per day, on top of DS also we can go do the round robin.
Let me just show one. So this is my fact table. See, slash basis, this is my fact table of a cube. If I open the definition of it, see, there's no key here. Then the fact table is not going to have any primary key now. Okay. Since there's no key, can we have round robin partition on it? Yes. So it has got round robin. You don't create. By default, it is partition on round robin every time the fact table is created. Round robin, okay, one. Don't worry about range key. See, this is the round robin part. We got partition 1, partition 2, partition 3, partition 4. Okay, boss. And this part, every time you load some new data through DTP, it gets into what? Partition 4. Then we do compression whether it moves into 1 or 2 or 3 depending on the requirement. So round robin partitioning is about just providing a new set of block for all the new records what you insert. That's nothing else. And from there you're moving it other blocks, depends on how your application is handling it, how where it is moving, how it is moving. It's all your application will handle that. We are not worried. Okay.
If the table has a primary key, so this concept doesn't work.
It doesn't work. Yes.
Okay. Okay. Thank you.
Yeah.
So on top of DS also can you create, because DS also some primary keys are there. So this is also not applicable for DS also, right?
No, only for cube. Okay. See, this is how you just create round. If you want manually create round robin, you'll say partition by round robin, number of partitions what you want. But am I in the partition specification, am I specifying any column? And there's been no primary key in this table. Yeah? So let me just create a round robin. When I go to runtime information, I can see the partitions created. Round robin 4, and I see this 4 partitions. Okay. Then I'll say I'll insert these records. I'm inserting how many was? 6 records. It is doing. We are not able to control because there should be some programming at the top which controls it. Say there's an ABAP program with DTP which is controlling that all the records will go and sit into partition 4 or something. But here, application we're just loading something, it's just splitting across. That's all. But generally what happens, always you want to provide one particular partition for the new records coming in, so that only for the new records the delta merge is executed. Now already, let's say my queue already has got 100 million records in it. Again, you're loading 1 more million. If it's all there in one block, if I do merging is done on 101 million records. If I just create a separate block for the new records what is coming, so the merging is done only for those 1 million records. Will it improve performance of the merging? That's their focus. Okay. And next is your range partition. Now with the help of range partition, you can control explicitly based on the value of a field or based on the range values of a field, you can control which data should be sitting into which block. This will be mainly helping for query pruning. Means you can explicitly control, okay, ee query month wise undi, ee month kanta oka block lo pedtanu, aa month nunchi read cheskuntundi. So this will be mainly focusing on pruning this. Okay, now look at this. Until let's say I have data for 12 months, I'll create 12 blocks. Each block will be for 1 month, and then when you do reporting, it just data only for that particular month, whatever you need. That is called pruning. So when I use range partitioning, I can basically create partitions based on the value of a field or based on the range of values of a field, and explicitly control which data should sit into which blocks. And this will help me for query pruning. Okay, boss. Query pruning help untundi, and also the size of the table also can be increased. The limit of the size of the table also can be overcome. See, how do I create this? So when you want to partition by month wise, year wise, quarter wise, then we use this kind of partition, which is range partition. Now look at this. I have a table with order ID, order date, net sales, and some primary key, where both order ID and order date both are primary keys. And even in case of range partition, again you specify a column. At a range part is simple. For this field, for this value, it has to be in one block. For this field, for this range of values, it should be in one block. You can specify the range or single value. Okay. So now, when you do partitioning with range, the partitioning specification will have to have a column. A column ki A value ki block. E column ki E value ki block. and this column must be part of primary keys. It need not be complete primary key, but should be part of primary keys. Let's say order date is not a complete primary. What is my complete primary key of this table? Order ID and order date together. It must be part of primary key, but to have it to be used in range partitioning. Okay. Now look at this. I'm just going create column table so and so. See how I'm creating? I'm just saying create column table, so and so table here with these three columns, and my primary key of this table is what? Order ID and what? Order date. And then I'm saying partition by range. I would like to go with what? Range partitioning. Which column to be used? Order date. And what are the partitions I have? Now I cannot, while I'm specifying the blocks or partitions, I can go with single value, I can go with what? Range also. Like see, here I'm going with range, saying partition 2015-0101 and what? 2015-060. What does it mean? This is greater than this and what? Less than this. Am I specifying a range of values here? I'm saying partition 1 is like 2 value. I'm specifying a range from this date to this date. So one block. Look at the others now. Look at the next comma, and I specify partition. Partition value equal to so and so. What is this here? Is it range or single value? Okay, date. E date సంబంధించిన రికార్డ్స్ ఒక బ్లాక్ అని చెప్పు. And then partition others means what? Any data which does not satisfy either of those criteria should get into rest of the block. That is rest other. Partition others. Okay. So I'm just creating this. Range part, open definition. So I've created three partitions, right? One is from 1st of Jan 2015 till 1st of June. One is 15th August 2015. Then one is rest all others. Okay? Then let me insert data into this. See, I'm inserting some data which will satisfy. Look at this. These two will satisfy which condition was? The first condition, range from 1st of Jan to 1st of June. This one will satisfy exactly 15th August, which satisfy second block. And what about this one? They don't satisfy any block, they get it others. So 2, 1, 3 Raval. Now here, based on the value of a field or based on the range value of a field, you're explicitly controlling the records in a partition. This is explicitly for query pruning. So that query would know when you run a query saying only for 15th August 2015, it will not scan through all. It will just catch hold of only one block and then picks the data. Right? So this is for case of query pruning. So if you just get into this, see, you've got number of records. First partition has got 2 records. Second partition 1 record. The last one, others has got 3. Now here did I control which record should get into which block? And then based on my reporting requirement, I can create my partitions and keep it ready so that my query will leverage to read only from one block. Then query pruning is used and improves my query performance. This is query performance scenarios. So can I say range partitioning explicitly for improving query performance? And then round robin explicitly for delta merge operations. And hash partition is about load balancing and going through the limit of size of the table. This is requirement. Got this part. Okay. See, now the question is another requirement. I have got order date in a table, but I would like to create partitions based on month wise. Now table of data only. Previously we had date, we did partitions on the date, but my table has got date based on the month, based on the date. I would like to derive month, and based on those months, it has created my partitions. Yeah, so I can use the function month of and a function. So I can say like this. Look at this. So create column table so and so, order ID, order date, net sales, primary key is both. But I'm saying partition by range. I want range partitioning, not based on the order date, based on the month of order date. So I'm using the function saying what? month of order date from 1st of Jan till June of, see, I'm specifying month or date now here. Month here, yeah. And then for August separate block and for other partition separate block, yeah. So date, or suppose you want to go with year wise, you can say year off, and I can use the function. Year off.
Sir,
Yeah.
so irrespective of year, can we partition with month? Means all January months will be stored in partition 1. All February months in irrespective of years.
Yeah, if you want, you can do that by SQL statement, but not with UI. With UI, you only have two functions can be leveraged, month of or year of. But here, if you want to go with only month, you can say month number. You'll have a function which will just give me only, it does not give along with year. It just gives me only month bus. Then use that column for creating range party. Any field you can use. See, range partition is not for either month or year, or like in BW we had only calendar year month. You can use any.
That's what.
I can use employee number and say employee number 1 to 10 as one block, 10, 12, 11 to 20 as one block, 21 to 30 as one block. I can do that. But when you're creating, if you have a column in the table which already gives you month, straight away, it is straightforward. But if you have order date and then you want to derive only month, then you must use a corresponding function accordingly. Month or year. That's it.
Okay, thank you.
Yeah. Open definition.
Sir.
You see this block which is created on the month wise.
Sir, here we are.
See, this is 1 second. I'll let you. So again, the first two will be in the first block again. Two, 1 and 3 bus. And same kind of range partitioning I can do with UI also. What will I say? So I'm just creating the table as it is first. Range part UI, and I would like to, so right click on the tables folder, then say what? Table distribution. I can say range part UI, right click and say partition table. You would like to go with what? Range partitioning. In last, which column you would like to use for partition? Order ID or what? Order date. Okay. Do you want to use any of the function? Year of, month of. Only rende. If it is, you already have a column. What you do is make sure you have a column in a table which holds only the month number. Then use that column for partition. Then I don't have to. You have a date and then you want to derive. Then I have only two functions. Make sure you have a table with a column which holds only month. Then use that column for partitioning. Then there's no point. Okay. Okay. If you want to go with that saying, now you're saying where this field is equal to null, you're trying to partition a table based on the value of a field or value range of a field, then it has to be range partition. I want to go with year function. Function was rende unnai. I never year month kaakunda just month tho kavalana. Appudu emanante you make sure the table definition such that it has got a column called which will hold only month, then use that column and create partitions. But if you have a date and then you want to derive, you have only two functions, year and month. That's all. Here you can say value. Here you can say single values. You can have value range from 2010 to let's say 2014. Any range lo ichukochu. Rendu range lu from 2015 2020. Rendu range lo single value ఒకటి కావాలి. Where 2021 ఇదో ఒకటి. Like this you can specify with the range or you can specify with single values. Check input, everything is fine, okay, and then say finish. Open definition. You'll have the partitions created on for 3, 10 to 14, 15 to 20, 21, and this what? Others. Okay, like this you can create range partition. Hash and range you can create with UI. Round robin only with SQL only. Now there is a concept called multi-level partitioning. Okay,
Sir, range partition, you are on one question, sir.
one second. Yeah.
You are declaring range partition by order date, right? That order date must be also primary key, right? Without primary key, you cannot declare, right?
It need not be a fully qualified primary key. It must be part of primary key. Okay. So now let's see your. Yeah.
You mean to say part of primary key means if you have order date is primary key now. So if you have any creation,
I have a table with 16 columns as primary key. Column 1, column 2, column 3. You can create range partitioning by using either of this column.
Okay.
Okay.
Fine. Okay.
Partition of based on order ID, and it is alphanumeric key. Suppose if there is an order ID, then also.
You would put whether it is numeric value. See, even my date is also alphanumeric only.
Okay.
Date data is also alphanumeric only. Na? Alphanumeric or numeric kaadu. Range value specify cheyagalugutava. Do you have something like say select data from this table where my order ID is 1 to 10? Are you able to specify some where class selections like that? Then range partition between a single value and system. Then it has to be range partition. Okay. Yeah. Okay. Okay. Now I've got range part here UI. Okay. There's table. Now apart from creating part, I can also do what is here? Merge the partitions. Let's say I created a partition from 2015 to 2020. Then there's one more partition 21. I would merge those. I can do that. If I open the table. You will get the control again, but with SQL, see, just refresh. All the partitions have been merged as one. But with SQL, you can control the partition. This should be merged or what it is. We will see in the alter statement. Okay. Multi-level కూడా చేయొచ్చు అంటే multi-level. Okay. Multi-level. Okay. I would like to create multi-level partitioning on this. Show table distribution. I'll say what partition table. First, I would like to do hash with 4 partitions. Then within each hash, I would like to have range partition. So I'll say hash first. So I would like to go with red is all. Okay. Sorry. I want additional level of partitioning, which will be range. First level hash, additional level range. Okay. First hash will be since both are primary key, hash must have both the columns. Okay. Then for range, I can choose any column. What order date? Here. What is all? Okay, was finish. Actually, two hash partitions, two range partitions, but two range partitions are under each hash partition. Okay. So, the table first you'll have partitions as what? 1 and 2 are hash. Now, within each hash partitioning, you'll have two block what extra node and others. 2000 to 2005, 2006 to 2010 and others. And again hash partition again 2000 to 2005, 2006 to 2010 again hash. This is called as multi-level hash to hash level multi-range. That is called as hash level multi-level partition. Say, so with this, I could distribute my table content to multiple servers, which will enable me load balancing, yeah, and overcome with the limit of the size of the table. And since I've got within again each host, I've got range partitioning, which can again help me for query pruning also. I've got both the benefits now. If you want to get the benefit of delta merging and query pruning, I'll say what? Round robin first. Now within round robin, I can go with what? Range partitioning also. At a multi-level range, depending on the requirement. Okay. For BW, generally you do the partitions. In HANA, generally this is all taken care by administrator generally. You don't deal with, you don't not have authorizations to create partitions. You'll be only analyzing that you say, I want this partition. So it will be all done by the administrator general, but you should have knowledge on partitioning, how it is done, what it is done. Okay.
You can do any two.
Sir, I have one question. In this case, how a delta specification will be taken care?
How?
How a delta merge concept is there, right? That,
yeah. How that is improved?
Yeah, how that can be improved in this case?
Exactly. In case of, let's say, in case of round robin, the concept of round robin is what? Whatever the new records you load, that will be loaded to a new block. So let's say there is a table with say 10 partitions in round robin, and we say partition number 10 is the one which will actually holds the new records every time you insert. Okay. Let's say you insert 5 records. The 5 records what you insert newly will be into which partition now? 10. So when I say merge this table, all partition 1 to 9 has got no data now. Only 10 has got data. Now when I do merging is done on which table now? Which partition? Partition number 10. Let's say your application takes this 10 records to, let's say, partition number 1. So now partition number 10 is again 0. Again you load some new set of records, say, which is 10 records. So the 10 records will go to again which block again? Let's say we are assuming we have configured partition 10 for the new set of records. So the 10 records will go to partition number 10. Now when you do merging, see, the data is available in two partitions, partition number 1 and partition number 10. But the records of partition 1 are already merged up. Right? After merging only we have sent it to partition number 1. Now when you do merging, will you do merging for only partition number 10 again now? With only what? 10 records. Instead of 15 records, it is doing merging only on 10 records. Now will it improve performance of merging? Instead of merging all the 10 partitions, it is merging only on what? 10th partition. So with round robin, you're improving performance of delta merging in this case. That's the main point. That's why your BW cube is not focusing on query performance, because even though data is stored in detail, it can handle the performance of the query. It is mainly focusing on improving the performance of delta merge, because you will have huge data getting loaded. So their focus of fact table is on improving delta merging process, not on the query. They're not worried about query performance in HANA, because even though data is stored in detail, it can handle the query performance.
But only for inventory scenarios we are using cube. For other scenarios we are using DSO, right?
No, already with the latest 7.5 SP 7.5 we are able to implement inventory also with advanced DSO. We don't need cube even in that case.
Is it internally implementing the concept of cube?
Cube.
We are using
internally implementing concept of cube. Yeah.
So how does this work in scenarios like inventory and normal any other cumulative models?
See, if it is cumulative cube, only partition 1 and partition 4 will be used, and where the partition 1 will be leveraged as if it is an E table, and partition 4 will be leveraged as if it is a F table. That's it.
So even in 7.5 we will be using something, we will be using round robin, right?
If it is cube, it is round robin. Whether it is 7.4 or 7.5, it is round robin if it is cube.
So we are talking in scenarios where we are using advanced DSO.
In advanced DSO, we will not have any round robin internally in the backend. No.
But for this inventory scenario, so how does it work?
It will have something called record type internally. Through record type, it will be differentiating that record. That's it.
Okay, thanks.
Yeah.
Thank you.
Still, they're not yet implementing. Still, they're using cube only. But there is a concept already out where you can say that we can also implement inventory with advanced DSO also. Yeah. Still, they have not yet implemented, but still, there is an option to implement with non-cumulative key figures also.
So what if there is no compression in another field? So how does it improve the delta much?
That's the he's saying. If I don't look at this, all the new data what is coming is sitting into which partition? Partition number 4. When I do compression, the data from partition number 4 is going and sitting into partition number 1. If I'm not doing compression, then all the data is sitting in what? Partition number 4. Then am I improving performance of delta merging? No. So we have to do compression in the cube, not to improve performance of the query, to improve performance of delta. No line like what's not there. So in BW now we still do compression, not because to improve query performance, to improve what? Delta merging operations. So the concept of round robin and compression becomes mandatory for me to take care about delta merging performance. What is the understand? In even with BW or HANA, do you still do compression in the cube? Yes. We still do compression in the cube, not because to improve your performance of your query, but in order to improve the performance of my delta merge operation. If I hold all my data in the same partition, there's no point in improving performance. It's like as is like single table holding all the data in it. Then merging is always executed on all the records. Doesn't make sense. Okay. Okay. Next is about altering table. Yeah. So when you say altering table, we've seen about create table statement. Now we are focusing on altering table. So the table is already created. Now I would like to change the properties or settings of the table. Let's say I'm using this table. First I'm just creating this table. Shall we see it tomorrow? This one. Now it's better. Now is it better now? Yeah. It's better now. You're able to hear me when I try to speak continuously. You're able to hear me without any break. Is it fine?
Yeah, when you speak.
Now it's better, right?
It's better.
Okay. Yeah. So now, I'm going just creating a table and we go deal with the word. This is already created. Okay. So I'm just creating this table and we'll try doing changes to this table. EMP tab for alter. This is my table. So I've got different alterations can be done. Now first thing is I would like to see after the table is created, can we add a new column to it? Let's say There's already a table with the employee ID, employee name, department number. I also want to add one more column, department name. Can I do this? Yes. Alter table, the table name which you would like to alter. And then what alteration do you want to do? Logically, you'll have a statement. Okay. You want to alter this table. Okay. What alteration do you want to do? You want to add or drop or rename? What is it? What alteration do you want to add? Right. So add, and then give the details of the column with the column name and the date type. Just give this and say. You can see this column been added. Same way, I can also, if there's already date, if there's already column in the table, I want to remove this. I can also do a drop. Let's say. I would like to alter the same table again, but what alteration do you want to do is about what? Drop. So drop the column. So like this, I can add a new column to a table. I can remove the column which is already there in the table, even when there is data. Without HANA, in case of BW, can you delete an info in the queue when there is data bus? If you had, you could add that. But if we had never had a flexible removing, but now we can remodel the queue even when there is data, I can delete that info object also. Each column separates out. Now, so now it's not about altering. Now I would like to change the definition of the column. Yeah. So for example, I have a column with the department number varchar as what is the length here? 5. I would like to increase that to what? 10 numbers. Okay. Now alter table so and so, alter this column name and give the new new data type what you want. What is var 10? So now that gets changed with varchar 10 length. Like this, you can alter the table definition column. Okay. But yesterday someone asked me, I have a table with varchar and I would like to change that to date type as date. Not possible. You cannot change the column from date type to varchar to integer to decimal to, you can't go across. Within a similar set of data types, you can increase. Let's say I've got a column with integer, I can make it as big int. Possible. I've got double, I can make it real. I've got varchar of length 10, I can make it 20. I can do that way. But I cannot go cross from varchar, I can't go to integer, from integer I can't go to decimal. That is not possible. Okay. See now, I have integer. Now I want to make it is possible. But from this varchar, I can't convert to that integer. Not possible. Yeah.
So that can be done through a script, I mean SQL script that you are saying, or it cannot be possible at all?
It's not possible at all. Either with SQL or with UI, you can't change that. Not possible at all. Okay. So you're saying if it is with UI, you will change the data type here. That's what you're saying. No, see, you can't change that. Okay. If you add new column, it will give, but here for this, it does not allow you to change the drop down. Either with UI or SQL, you can't change the data types. Within a similar data type set, you can change, but not to cross. From integer to varchar is not possible. See now from integer, I could change it to big int. From integer, I can't change it to varchar. That is not possible. Okay, adding
so number to number and string to string we can.
Adi logic, yes. Yeah. Number to big number, small number to big numbers, or string to any kind of string, yeah, but not string to number is not possible. Now you can also alter the table by adding a constraint primary key. For example, I don't have primary key yet. I would like to set that as primary key. See, most of this you can get it edit and do with UI also. Right click and set it and you can do right. Edit log I'm removing edit. Okay. Now let's add primary key. Now we have the primary key switched on. See, primary key has been enabled. If you want, you can drop the alter table. So and say what drop primary key. You can drop the primary key what is already there. Right, removed. ఇది చాలా important. Very important. So you need to know this concept. See, whenever we switch on, let's say this HANA server is down and you restart your HANA server. When you restart the HANA server, by default, all the system tables, okay, and all the system tables are by default loaded into main memory. And apart from the system tables, if there are any column store tables for which preload flag is enabled, even those tables will also be loaded to main memory. If the preload flag is not set, those tables are not loaded at all. During the first time when you fetch the query on the table, then those tables are loaded into main memory. You got this point? This understanding is fine. When you switch on the server, only all the system tables will be row store, will be loaded to main memory bus by default as soon as you switch on the server. Apart from those, it will also load column store tables from disk to main memory or RAM, provided preload flag is enabled for the table. If preload flag is not enabled, this particular column store table is not loaded into main memory as soon as you switch on the server, not loaded at all. But when you run the query on the table, during first reading on the table, it takes the data from the table, loads it to main memory, and then gives you the result. If you feel the table is really critical, you want the table always to be in memory, then what you will do? You will enable as preload. So what happens? Even the server is switched off, and when you switch it on again, this table will be by default loaded to main memory automatically. You don't have to wait until till the first fetch. So, but while creating a table, we could not enable preload. Only with alter statement, I can say whether for this table preload should be enabled or not. Preload flag, it's all important. Okay. So how do I do this? Now look at this. Alter table so and so, preload these tables. Now when I say preload these columns, does not mean to load. See, the three things: load, unload, preload. Load is like what? Explicitly, when I say load this table, when you execute this statement, then this table is loaded from disk to main memory at that point of time. When I say unload, the data is removed. When I say preload, you're only setting the property as preload so that when you restart the server, all the column store tables for which the preload flag is enabled will be loaded to main memory. Okay, and that can be set for partial or full. If you do not, my table has, let's say my table has got 100 columns. You can set the preload or load or unload partially or fully. Either all three things can be done fully or partially. Fully ante anni columns, partially ante konni columns annattu. Now look at this. My table has got 3 columns: employee ID, employee name, and department number. If I say alter table so and so preload these 2 columns, what does it mean? I have switched on preload flag on this table, but only for 2 columns only. Is it like preload enabled for partially? So whenever I restart my server, first it will load all the system tables. Then it will also load this table. Which table? EMP tab for alter also is loaded to main memory because preload flag is enabled. And will it load all the columns of the table or only 2 columns? Only 2 columns. Then preload all on. When I switch on the server, all the system tables are loaded. Then when it has to reload the column, when it has to load the columns of the column to store tables for which the preload is enabled, all columns are loaded to main memory. Server starting number. Server starting number konni columns load kavalna, anni columns kavalna. Preload and jeppi columns list is a columns load aithe, and if this is a preload all, entire table will get loaded. Okay, boss. Yeah. Yesterday I showed you a query.
Do we have preload option on BW? I mean, info providers?
Yeah.
BI?
Yeah. So ultimately, even if it's BW HANA, you can log into this HANA data. I showed you just now a schema called SAP BW 1. That is actually your BW schema. Yeah. I can get to that and enable the tables for preload. Okay. SCHE schema. And when this preload flag is enabled, this table will have the property enabled, whether preload set in the ledan ikkada chudochu. For a particular table, you can know whether preload is enabled or not. Compressed key. Look at this. Is preload, what is it says? Is partially reloaded, preload కాదు మంది all కొట్టినాం అంటే what is preload true bus. So when you switch on the server, all the system tables plus all the columns for which this property is preload is set to true will be loaded to main memory by default. Okay, numbers. Are two columns I think.
So preload is used for what scenario, sir? For query execution or
yesterday
for data inserting or?
No, not data inserting. We classify the data as hot, warm, and cold, right? So there's some part of data
Yes.
to be really critical, and it has to be. You want that to be always be stored in the main memory, and you want it to be available for reporting at faster rate, faster speed. So what you do?
Okay.
You enable those tables. You will enable those tables as preload. Then what happens? Even though server is down, and when they restart, those will be by default loaded to main memory for your access bus. If not, all those tables will be in column store in your disk only. When you run the report first time, then it will read those tables and place them into the main memory bus. So then first time the performance will be down, because first time it is trying to read from the disk, it is like the performance will be down, right? You don't want even that effect, and for those tables you will enable as preload bus. Preload పెట్టలేకపోతే ఏమవుతుంది, సర్వర్ స్టార్ట్ అయినప్పుడు ఆ టేబుల్ రాదు మెమరీలోకి. అప్పుడే కొట్టినప్పుడు ఫస్ట్ టైం క్వరీ కొట్టడం ర్యామ్ లో దొరకదు కాబట్టి డిస్క్ లో తీసుకొచ్చి ఫస్ట్ అప్పుడు ర్యామ్ లో పెట్టి అప్పుడు రిపేర్ క్వరీ తీసుకొస్తుంది. సో ఫస్ట్ టైం క్వరీ కొట్టినప్పుడు సెకండ్ టైం మళ్ళీ ఎత్తుకుంటుంది. అట్లా అది ఈ డౌట్ ఏందో.
ఓకే. సో లేటెస్ట్ సేల్స్ డేటా కావాలంటే we need to do this preload.
మామూలు రియల్ టైమ్ సర్వర్ డౌన్ కాదు, బట్ ఒకవేళ మెయింటెనెన్స్
వరస్ట్ కేస్ లో
మెయింటెనెన్స్ డౌన్ చేసినా ఆ టేబుల్ ఆటోమేటిక్ లోడ్ అయిపోవాలనుకో ప్రీలోడ్ ఫ్లాగ్ సెట్ అడుగుతాడు. ఇది ఇంకో డిస్కషన్ లో ఉంటుంది.
Okay.
In case of partial preload, can we load data on the basis of some date range or loading the full data?
మళ్ళీ డిఫరెన్స్ తెచ్చుకోవాలి. What is the doubt? What is it?
In case of partial preload, can we load the partial data on the basis of some date range?
No. Only columns. You're saying, can I do partial selection preload for certain row wise? No, it's only column wise only. Because it's a column store table, only column wise allowed, no row store.
So no where class.
No where class. Okay. Then we have another alter statement where we can convert the table from row store to, let's say you created a column store table, I want to convert that to row, and if you create a row column, either ways, okay, I can convert. Say for example, this table is already a column store. I cannot edit this in the UI, but I can do this with SQL. I say alter this table, alter the type as row. Now this becomes a row store table. It says what? Row store. But you can't do that with it, but again I want to change it to column. That will be back to column. Okay. Range part month. So I have this table. I got a partition till August, right? July undi. 7th July kada. July undi. Now I would create one more partition for August, like this here. So by using add partition, you can add a new partition. Last class, we are almost done. So alter table so and so, add partition, we'll add new partition to the table. Like this, we can change the partitions by adding a new partition. So get new partition. Later you want to drop an existing partition again, sure. You can add drop partition and where the value is shown. and that is dropped again. Like this you can add drop, yeah, okay. And then yesterday I was telling you about disable and enable auto merge. Let's say while creating a table, you have switched on the auto merge. You said on auto merge, but later you decide that you want to switch it off. Then you'll say what? Alter this table, disable auto merge, right? Straight away, then you can. When I create this table, by default, what is happening here? Auto merge is getting enabled. So now I would let disable auto merge on this. Then what will say? Alter table so and so. So what? Disable auto merge. If I say export this table, you can see this here. Where was that? You remember I showed you in this tables for tab, you can see whether auto merge is enabled or disabled. So this is just like using option disable or enable auto merge. Then again, next is unload a priority. Let's say you already created a table. While creating table, you have set up unload a priority, let's say 5 or 6 some number, and you want to change that priority later. Then you can say alter table, unload priority as what you want. You can change those unload priority of a table also. So higher the number it is, more earlier it is unloaded, and lower the number it tries to hold that back in memory. Critical tables ki unload priority taggiso, but then important it will have higher unload priority.
How to give this priority number? We said that condition based on the row RS underscore schema.
దీంట్లో చెప్తా దీంట్లో తెలుస్తాను కదా మొత్తం అన్ని తెలుసాను అన్లోడ్ ప్రయారిటీ yeah. Is preload, is partial preload. Unload priority is set to what? 0 here. Now I'll change this to still 0 only. It's not in the unload priority range part month. Okay. Table name is different. I change it to range part month. You can see. Pretty much you see all the table information in the table called tables, then you get to see more pretty much. This is about altering table, and so you know about creating table and altering table. If you want to delete a table, simply just right click on this and say what? Look at this here. Say delete. You want to delete rows or table? Table, right? No, not table. So I'll say what? Make sure you select this data as what? Delete catalog object. Then restrict to cascade. If I say restrict, if there's any different objects, it will not allow you to delete this table. Say there are different objects on this table. Cascade కొట్టినామంటే ఈ టేబుల్ పోతుంది దాని మీద డిపెండ్స్ కూడా ఎత్తిపోతుంది. Suppose there is a table on table 1. On table 1 you create some 5 views. If you say restrict, it will say this table cannot be deleted because there are 5 views depend on this. But if you say cascade, it will delete this table and also the 5 views on which are depend on this table also deleted. Okay, like this you can either delete or nothing but drop. This is how you can do with UI. Okay. If you want to do with SQL, then you will say what? Drop table. Which table you will say? So and so table. And when here you can say cascade or what? Restrict. So I'm dropped this table with all the dependencies gone. So if I say drop table, so it's a restrict anko, it does not allow you to delete this if there's any dependencies. So you can do that with UI. You can delete with UI like this, delete, or with what? With the drop statement. Now you know about creating table, you know about changing a table, you know about dropping the table. Okay. And we'll stop it here. Tomorrow we'll get on to this database views and the synonyms. About those videos, you asked for every 2 days. They're still working on it. Today or tomorrow you should start receiving it for every 2 days. Okay. There's still some problem. There's still yeah. Understand. Actually, they've done some setting for 5 days. Now when they're changing it for 2 days, they're not able to do. Just give me time till today and tomorrow. We'll solve that problem. Okay.
Sir, I have one question.
Yes.
Some of the students have received some documents yesterday in the email, like the course content and demo files, but I think all the students did not get it because I did not receive anything like that.
See, if you're not receiving anything, just always contact these numbers. Yeah, 98853844656. Yeah.
Okay, so the problem is we won't know if we didn't get it or not because we don't know what to expect and what not to expect. So we won't know if we're missing something.
Generally, if you're not receiving anything, then you're saying, how do I know whether I've missed out something or not? But make sure your mail ID is right, covered. Make sure your mail ID is in his distribution list so that you will be receiving it at least. Yeah. Just call up. Okay. And say whether your mail ID, because when you're logging in with in the online, when you log from the attendees,
I'm getting the email. I'm getting the class link every morning, but I'm not getting these type of files.
Just make sure. I think you should just tell him once. Yeah, please.
Yes, sir. Thank you, sir.
Okay. Fine, boss. We'll meet tomorrow. Thanks.